This is Euclid Book 7, proposition number 15. Yeah, these things get a little longer. If a unit measure any number and another number measures any other number the same number of times, alternately also the unit will measure the third number the same number of times that the second measures the fourth. I know you're scratching your head again. Alright. Diagram time. Let's go through this, shall we? For let the unit A measure any number BC. Well, of course, we're going to make this particular unit 2. I know a unit number really technically is supposed to be 1, but we're going to say 2 on this one, okay? For let the unit A measure any number BC. Okay, so 2 is going to measure 6. How do we know that 2 measures 6? Because 2 times 3 is 6. Okay, and let another number D measure any other number EF the same number of times. Well, we're going to make D 4, and we're going to make EF 12. So 4 times 3 is 12. Okay. I say that alternately also the unit A measures the number D the same number of times that BC measures EF. Let's take this very slowly. 4. Since the unit A measures the number BC the same number of times that D measures EF, which we've already stated, therefore, as many units as there are in BC, so many numbers equal to D are there in EF also. Well, in BC we have 3 units. In EF we have 3 units as well. Okay. Let BC be divided into the units in it, which is BG, GH, and HC. Okay. We did that. BG, GH, and HC, which you'll find on the top. Okay. And we're going to have EF divided into the numbers EK, KL, and LF. Now EK, KL, and LF are equal in length to D. And since the units BG, GH, and HC are equal to one another, and the numbers EK, KL, and LF are also equal to one another, what does that mean? Well, BG is the length of 2, GH is the length of 2, HC is the length of 2. EK is the length of 4, KL is the length of 4, and LF is the length of 4. Okay? While the multitude of the units BG, GH, and HC is equal to the multitude of the numbers EK, KL, and LF, which we've already established, there's 3 units in BC, there's 3 units in EF. Therefore, as the unit BG is to the number EK, well, okay, BG is 2, EK is 4. As 2 is to 4, so will the unit GH be to the number KL. Well, GH is 2, KL is 4. And HC is 2, and LF is 4. So as 2 is to 4, so as 2 is to 4, and so as 2 is to 4. So far, so good. Therefore also, as one of the antecedents is to one of the consequents, so will all the antecedents be to all the consequents. What's an antecedent? That's the top number of a ratio. Just like the top number of a fraction. What's the consequent? That's the bottom number. So 2 is the antecedent, 4 is the consequent. As 2 is to 4, so as 2 is to 4, so as 2 is to 4. Okay. This is by Euclid Book 7, proposition number 12. Therefore, as the unit BG is to the number EK, as BG is to EK, as 2 is to 4, so is BC to EF. Well, what's BC? 6. What's EF? 12. So as 2 is to 4, so as 6 is to 12. But the unit BG is equal to the unit A. Well, BG and A are the same length of 2. And the number EK is equal to the number of D. EK is 4, D is 4. Therefore, as the unit A is to the unit D, as 2 is to 4, so is BC to EF. Well, BC is 6 and EF is 12. So as 2 is to 4, so as 6 is to 12. No doubt there. Therefore, the unit A measures the number D the same number of times that BC measures EF. Well, A measures D twice, and BC measures EF twice. And that's it, people. I will tell you more in a future video. Stay tuned.